Now that we introduced these new definitions of basic and non-basic variables, there's another result we will not prove, but will be very useful when we develop the network simplex algorithm. Let's go back to the original problem. We tried to introduce, we first introduced bounds as shown here, and then we had an option of adding them as regular constraints, and now we've developed this option of adding them as special constraints. Now let's see what another consequences of specifying them as special constraints. Since we will not be adding them in this way, let's just erase this, give ourselves a little bit more room. So before we introduced bounds at all, okay, before bounds were added, we had 4 variables, 2 shown here, and then we'll have 2 more slack variables. So we have a total of 4 variables and 2 constraints, and we've rehashed over that 2 of those will be basic and 2 will be non-basic. So what we have is 2 constraints implies 2 basic and 2 non-basic variables according to old definition. Okay. Now, after, so this is before, after bounds are added, but treated with a modified simplex and with the new definition of basic and non-basic, we will still have that 2 constraints implies 2 basic and 2 non-basic variables, but according to new definition. So what we will have is that we can state without proof that 2 of the variables will be floating and 2 of the variables will be at one of their bounds. So we cannot have, we can say right away that a basic feasible solution, what we used to call a basic feasible solution, which used to have 2 positive and 2 zeros, now translates as having 2 variables that are floating between the bounds and 2 variables which are at their bounds. So we cannot have a basic feasible solution that would have x1, x2, x3, x4 floating between their bounds. At least 2 of the variables must be at their bounds. Now x3 and x4 are between 0 and infinity, but the 2 have to be at their bounds and 2 of them are floating. Now in a degenerate, if we have a degenerate solution, then we would have, just like old degenerate solution meant having basic variables at 0, now it will mean that even though a variable is basic, it will be shown as one of its bounds, which is a little bit confusing, but we have to get used to that. In network simplex, we have a lot of times degenerate solutions, but it will not be as problematic as it may seem. So that's this completes the treatment of bounds in LP to the extent that we need it for the network simplex.